Hello everyone and welcome again. So I've received this message from Allred500. He says, hello, do you know something about Moore Mealy machine? I have a classic problem to solve about traffic lights and I don't know how to start, and I need to solve this problem for the next Thursday. 1 bridge, 2 traffic lights, north and south, 2 sensors. If you know how to, please answer and help me in this project. Keep the nice work, best regards. Okay, thank you very much. First of all, I would like to tell you guys that I prefer that you write your questions in the comment section because instead of sending a message, because my YouTube settings notifies me only for the comments, not for the messages. Besides, if you write it in the comment section, if someone else shares the same problem, then he can also add to your problem. Second of all, thank you very much for asking this question. Like, this is the most perfect question ever, because I love the digital logic design, the zeros and ones, and besides also my project for this course, the digital logic design course, was actually designing a traffic light too. It might be different than yours, but I'll give you some experience. First of all, I'll be talking about Mealy and Moore. And why did I write them before I start this video? Because sometimes I say Maury and Meal. That's funny, right? Okay, the Mealy and Moore. First of all, we'll start with the Mealy because it's more common. So we'll have. Wait, let me check something. Mealy, yeah. So we'll start with Mealy. Let's say we'll solve only one example for both kinds. Let's say you were asked to design a machine that detects the sequence 1010. So if you want to solve it the Mealy way, it might be a bit harder, but it takes less number of states. So for Mealy, we'll have 4 different states: 0, 0, 0, 1, 1, 0, 1, 1. And then you start by going starting from the first state. If you get a 0, then this is not the sequence you need. So if you get a 0, you'll stay at your place with output 0. So you write the input and the output. If you input a 0, you'll get a 0, but you'll stay at the same state. If you input a 1, then you will move to the next state, because basically oh, you didn't see this. Okay, because basically 1 0 1 0 is a sequence. So if you have a 1, where is Mealy? You already know that this is Mealy. If you insert a 1, you'll still have output 0, because output 1 is only when you get the sequence 1 0 1 0, but you'll be moving to the next state. If you got a 0, you'll stay at this one. For the next state, if you got a 0, you'll move to the next state, because we have a 0 here, but still the output is 0. However, if you got a 1, at this state, you'll have to go back again, because 1 1, then you have to reset. No, if you got a 1, you don't go back. You basically will stay at the same state, because you already have 1, so you'll stay here until you get the 0. So you'll stay here with output 0. After that, if you got a 1, you'll go to the next state with output 0. But if you got a 0, you will go back to which state? 1 0 0. Then you'll have to reset again, so you'll go back to the first state, the output 0. For the last one, if you get a 0, you will go to the you won't go to the first. Sorry, made 2 mistakes in one video. I'm very sorry. If you got a 0, you will go back to this state, because you already have a 1. No, 1, then you go here. This is 0. No, I'm sorry, making a lot of mistakes. So this is 1. is 0, so you'll go to this state. If you got a 0, but with output 1, because you already achieved the 1 0 1 0. However, if you got a 1, you will go to, so it's basically 1 0 1 1, so you will go to this state where you already have a 1, so be 1 and 0. So this is basically Mealy. So you start with 0, so you start here. If you got a 1, if you got a 0, if you got a 1, if you got a 0, then you get an output, and you get here, because if you got another 0, you will get another 1 0 1 0, because it will be basically 1 0 1 0. So you will have a 1 here and a 1 here, because it's the same sequence. And you have to be careful where to go back, because sometimes if you don't get an output, it's not necessarily that you'll need to go to the first stage. You can go to like a later stage, because you already have part of the sequence. This is how to solve it with the Mealy way. The Moore is much easier, but you'll need more states. Besides, it's less common. Like for my course, we used to deal with with Mealy Moore. So here's Moore. You'll have 2, 3, 4, and 5 states. 0 0 0, 0 0 1, 0 1 0, 0 1 1, and 1 0 0. Basically, for this one, you'll have the output not on the line, but on the same state. And you just plug, if you get a 1, you'll go here. If you get a 0, you'll stay at your place. But still the output here is 0, 0, 0, 0, and it'll be 1 here. If you get a 0, you'll go to the next state. If you get a 1, you'll get to the next state. If you get another 0, so it's 1 0 1 0, you will get the output 1. But for you still have to continue, because since you have zeros and ones, so each state must have 2 arrows coming out of it. So this one already have the 2. This one, if you got the 1, you will stay at the same state. This one, if you got the 0, then you will go, so it's 1 0 0, then you will go to the first state. If you got a 0. For this one, so it's 1 0 1. If you got a 1, you will go to this state. Over here with 1. For this one, you will definitely, like if you got a 1, you will go to this state. If you got a 0, you'll have to reset. So this is the basic difference between Mealy and Moore. I hope this was useful. Now let me show you, since you're asking about a project related to traffic lights. How many minutes are we? Oh, 8.5 minutes, we have to go fast. So let me show you my project. So here's a video of my project while it's functioning. Basically, I have to click 3 times for the green light. 1 2 3, and then it goes yellow for 1 second, and then red. At the same moment it goes red, it goes green for the other one. I had 2 lights, one for cars and one for pedestrians. Let me show you again. So 3 seconds for the green, 1 second for the yellow, and the rest are red. So how did I do that? I used this. This is the table. If you search online, you'll find that most of the traffic lights use mux or the multiplexers. However, in my project I used only 0 to 15 counter, a 16 counter, 4-bit counter. So the idea is that the 4-bit counter has 16 states. So I divided the states into 4 states, because in my project I had 4 traffic lights. Not 2 like yours, 4 traffic lights. So I had to divide the 16 seconds between these four, and for each time, like the reset button is for the red, or the common state is the red, and just whenever, like the first signal, when does it function, or it goes green or yellow, when we have the largest two digits as 0. The next one will be when we have a 0 and 1. The next one will be 1 and 0. And the last one when we have both are 1s. So whenever we have the largest two digits zeros, we will be connected to the first traffic light. And whenever we have 0 and 0 and 0 and 1 and 1 and 0, we have a green light. Only whenever we have a 1 and 1 for the small two digits, we will have the yellow light. So basically these are the smallest two digits and these are the largest digits. And in order to get the gates that choose the first traffic to be on, we connect these two, like over here. You can pause the video and check this connection, because I did this project like a year, like 8 months ago or something, so I don't really remember. You can pause it now. So basically I just tried to get the functions that whenever I have two digits as 0, you will get the high output. So this one will be working while the three other states are off. And basically I use the same concept for the small three digits. Is that when I have this cell on and I have 0, 0, 0, 1 or 1 and 0, this will be green, and whenever I have 1, 1, only the yellow will be working. And for the last two digits, I just use the same functions for the three of them, but for the three of them, but with different functions for these. So this is basically the idea of traffic lights, and this is the project using the ICs with ANDs, ORs, NORs, and the 4-bit counter. It was fun, and I really thank you for asking this question, because it's so perfect. I'm sorry for making some mistakes at the very beginning of the video. I hope you liked it. I still have, I'm receiving a good amount of questions from you guys. Thank you very much, and I'll keep solving them if you keep asking. Thank you very much. Thanks for the support. I've been receiving such positive comments. Thank you very much, and I'll see you in the next video.